So following on from the previous video, we're trying to come up with the parametric equations to describe this point here. So let's have a look at the animation. So we are trying to keep track of this green dot. So as you rotate it, so one cycle would take us up to here. So this is 2 pi here. It would take us up to 6 pi. So one cycle, hang on, let's start again. One cycle would take us up to here. So now let's look at it when we rotate it to the right slightly. Let's have a look at it when it's in this position. So remember, we are trying to come up with the parametric equations to describe this particular point. We are coming up with the parametric equations to describe this particular point. So the first step is to have a look at the circumference of the small circle. One rotation would take us up to 6 pi. So this distance here is really the same as the circumference of the small circle. So what we're going to do is we're going to get this whole distance here cut up into, so the whole distance is 2 pi times the radius of the small circle, and then cut up into 2 pi equal pieces. But let's not work in radians for the time being. Let me work in degrees. So get the circumference. So that's this distance here. Cut up into 360 equal pieces. So we're going to cut up into 300. Imagine there are 360 equal pieces. So I'm just using degrees to explain the concept to you. Later on, we'll need to work in radians. But let's just, in your mind, let's just imagine we are working degrees. So you cut up into 360 equal pieces. So one increment of the angle would mean you would move across by 1 in the x direction. Another increment in the angle would mean you jump to the right by 1. Another increment of the angle means you move to the right by 1, because we deliberately created a system where the angle here ties in neatly with all the segments in the x direction. So what that means is, what that means is, let's say this angle here is, let's say 7 degrees. Well, if you get this whole distance here, 2 pi small r divided by 360, so 1, 2, 3, 4, up to 360. So after, well, an increment of an angle of 7 degrees means you move to the right by 7. 1, 2, 3, 4, 5, 6, 7, and so on. So we created a system where the angle ties in neatly with each increment in the x direction. So now let's revert back to radians. We need to get this whole distance here, which will be 2 pi small r divided by 2 pi. So that would be 3. So this distance here would be 3 times the angle. 3 times the angle. It would be 3 times the angle. This distance here. Think about it. It would be 3 times the angle. So this distance is 3 times the angle. But if you're trying to keep track of this point, it would be. Hang on, let me think. It would be this distance here, which is 3a. Take away this length here. Well, if you look at this right-angled triangle here, the radius here is 5, radius of 5. And the angle here is a. So this length here would be 5 sine a. So if you want to know this location here, it would be this length, which would be 3a, and then take away this length here, which will give you a negative number in our situation at the moment. Take away this. So the x coordinate will be given by this thing here. That's why over here our x coordinate is given by this. Okay, so that will give us the x coordinate. Now let's try and figure out the y coordinate. The y coordinate, hang on, let me think. The y coordinate would be you getting the height here. The height here will always be 3, because the height, as the circle moves across, this height here will always be 3. And then if you want to know the y location of this dot, it will be the number 3 take away this whole length here. Take away this whole length here. Well, the whole length here will be, well, this is of radius 5, angle of A, so this whole length here will be cos 5 cos A. So if you want to know this location, the y direction, sorry, the y location of this point, it will be this length, which is 3, and then you take away this whole length here, which will be 5 cos A. So going back to here, that's why it's 3 take away 5 cos A. So that will then give us the location as A moves, as we slide A back and forth, it will always give us that location. So if you want the parametric equations, so this thing here, remember t is reserved within decimals. So t, well, A here is us sliding A back and forth. So t here you specify to whichever one you want, from 0 to wherever. It would take into account all the time values from 0 to 3 pi. So there's a difference between A and t. A, we can slide it back and forth. We can vary our A. Well, t is telling decimals to draw it from 0 to 3 pi automatically. Just do it straight away. Here we are sliding it back and forth. Well, anyway, play around with this. Punch this whole thing in into decimals and play around with it, and hopefully you can understand it. Okay.